Hello folks, welcome to lab number 11 of eDesign. This lab will cover information from chapter 7 and 8 of your Inventor textbook. And I do highly recommend doing these back to back because in chapter 7 you will be creating a part, then in chapter 8 you will be creating a drawing for that part. So let's jump right into chapter 7. I'm going to make a new part. I'm going to make sure that I have this in the units of inches, which I do. That's good. First thing that they show us in chapter 7 are some sketching options. So if you go to tools, where I'm at already, then application options, then click on the part tab up at the top. That gives us options there. If you just look over what they have, sketch on new part creation, no new sketch. That is kind of what you want generally, because that lets you decide every time you create a sketch, or every time you create a new part, which one, plane you want to make a sketch on. So otherwise you would have options. If you know you're always making a similar part, that you would always start on one of those planes, you could choose that. But in our case, we like to choose every time. And we also have the sketch tab way up here. And right now, this selection of looking at the sketch plane on sketch creation and edit is on in part and environment. We're going to try turning that off and see what happens. So I clicked off the check mark, apply and close. Now I'm going to go back up to our standard 3D model section. I'm going to start a new sketch and I will put it on the XZ plane. And instead of turning like it used to do and showing directly to the plane, what it's done is stayed in that isometric view, and we see the plane at an angle, which you can see a little better if I turn on the visibility of all of the planes. So you can see we haven't moved from our original setting. Now you can draw in this direction. There's nothing wrong with it. It does sometimes help to be able to view your drawing from different angles. Sometimes it's nice to just look at it from straight up and down. But we're going to start this time with a slot, and we're going to use the center to center version of the slot. And it doesn't really matter what size you make it, we're just putting it somewhere around here. And right now this isn't snapping horizontal for me, so I've just kind of made it at an angle. I'm going to click on the top view on my cube and rotate it. I'm going to click the horizontal constraint and make that center line horizontal, because I do want it to be horizontal. If I click to show all of my constraints, you can see that all of these are automatically, the arcs are created tangent to the lines, which is a nice thing about a slot. So you could draw all of this by hand if you wanted to, but the slot will do all of those things for you automatically. So we're also going to put some circles at the endpoints of that midline, and I've purposely made them slightly different from one another so that you can see what happens later when we dimension them. And I'll dimension this. And I have made a change to my dimensioning settings that you might like to do, so that it automatically will add the dimensions in here. So what you can do is when you have dimension selected, right click anywhere in the graphics area, click on edit dimension so that that is checked. That way, as soon as you create a dimension, it will allow you to immediately type in the dimension so that you don't have to add dimensions and then create the number later and edit them. It'll immediately edit it for you. So I want this to be 5 inches. That blew it up. So I'll zoom out. And they show having a dimension between the center point and here at 2.5 inches. I don't know why they show that dimension, because the way that this slot works, it automatically creates that dimension. So it will give you a note saying adding this dimension will over-constrain the sketch, and you can choose to accept making this a driven dimension, which is fine. If you click accept, it will show that dimension with parentheses around it, indicating that this is not a dimension you can change right here. This is a dimension that is governed by other dimensions that already exist. Now, let's continue dimensioning. I'm going to add a dimension. I'll add a dimension to the right hand circle here, and I'm going to make that 0.5 inches. And then I'm going to add a dimension to this one, and I will use a function here. And similar to Excel, you can start a function by typing equals, and then I'm going to click on the dimension that I want it to be equal to. If that dimension had a name, which you can assign, you can type that in there. I don't know what dimension number it is, but just clicking on it puts its dimension number in there. So if I click OK, it shows fx, showing that this dimension is a formula or an equation, and it is now equal to the other dimension that we showed. And let's see, 3 dimensions are needed. We'll do this. And the other 2 dimensions that are needed are positioning in space, which I've shown you before how you can constrain with the coincident constraint, put this center point to the center point of the origin on your plane. You can also use the dimensions. Click your center point or this line. I'll click my center point over here, and I want the vertical dimension to be 0. I'll again click that same center point, and this center point over here, and make the horizontal dimensions 0. Now my sketch is fully constrained. I can finish it, and I'm going to hit F6 to bring me back to my isometric view. I'll extrude this upwards 1/2 inch. Select the profile that we want. It is going upwards as we want. OK. Now we're going to make another sketch, and let's put it on. Since I can see my planes, I can click them. The XY plane here, I can also still click them over here. XY, let's turn to face it, and because right now we're seeing the solid model and it might be getting in the way of things we want to draw, let's go over to View, change our visual style to wireframe. That only shows us the edges of the model. Now if we want to do some drawing inside the model, we can still see where it is, but we can see the lines that we put in. So we'll go back to Sketch, and I'm going to do an arc, and I will use the center point arc. And we're going to start on the bottom face right at the origin here. So don't start on the top. You do want to start this on the bottom. Click first your center point, then arbitrarily we're going to keep it on the bottom face. It should snap to it. Any distance, doesn't matter too much, and then we'll click again when we get to the other side. And then I am going to put a line between those 2 points, and dimension the size of this, which you want to be 1.75. Now we're fully constrained because everything is held in place by existing relations, and we've got a size for the diameter of, or the radius of that arc, which also is going to constrain the size of the line since that line was drawn to the arc. We'll finish that sketch, and now we're going to extrude it. We'll make this a symmetric extrusion, and we want this to be 2.5 inches. Now we're going to create a rectangular cut that goes through this entire thing. We can either make the cut, I'm going to turn off the visibility of these planes because they are kind of getting in my way. You can, as the book shows you, you can make your sketch on the front face. You can also make your front or your sketch on the XY plane if you extrude it in both directions. I'm going to follow what the book asks us to do. We'll sketch it on this plane, or on this face, and I'm going to turn to face it, and we're going to make a rectangle. I'm going to use the 2-point rectangle. I'm going to start it on the base here, and we'll make it, I can add my dimensions right now, so I'll make it 2 inches across, and if I hit tab I can make it 1 inch high, but it is not yet centered. So what I'm going to do for that is I'll show you another example of using a formula. So the dimension, I will take this side to the center point, and if you want to use a formula, type equals again, and this time I'm going to make it half of the lengthwise dimension, so 0.5 times, and then I will click the dimension that I want it to be half of, hit enter. Now we're fully constrained because I started it on the bottom, so that keeps it in space that direction. This guy's keeping it where we want it, along the x-axis. We'll finish that sketch, hit F6, and now I will extrude a cut, and I am going to go through all of it. Click OK. Now you've got a rectangular cut through there. So I'm going to rename these so that they are a little easier to understand what's what. I'm not following exactly what the book says here, but this will be the base. And you can click and click again, or you can also click and hit F2, and that will allow you to rename something. So this one I'm going to call arch, and this I'm going to call rectangular cut. Next we're going to make a hole through the top. So I'm going to rotate my model. I'm going to start a sketch on, I started on this plane here, the face at the bottom. I'm going to make a hole, so it's going to be a circle. The center point should show up here when you hover over it, and I want that to be 1/4 inch. I'll finish that sketch and extrude another cut. through all. Okay. Now the next thing that they're going to show us is that sometimes you need to make a change to your model. In this case, we don't want this to be a rectangular cut anymore. We want it to be another semicircle. And in that case, sometimes maybe you're going to come back to it and show different options. So I don't want to get rid of this rectangular cut entirely in case I come back to it. So I'm going to right click on the rectangular cut and suppress it. That keeps its existence in your tree here, but it no longer shows up, and also any features that rely on the existence of that rectangular cut will also be suppressed because I drew that sketch on the surface that was created at the top of that rectangular cut, so that hole no longer exists. So we'll delete that, and we'll get rid of the sketch also with it, and we'll make a new sketch, and let's put it on the XZ plane. We'll do the same thing, 1/4 inch circle, and we will extrude it through all. And now if we unsuppress the rectangular cut, that hole is still there. I'm going to suppress it again because we don't want it to be there. I'm going to rename this hole, and we're going to make the semicircular cut that we actually want to be here from our design change. I also missed something else that they pointed out in the book, so I will unsuppress this and show that you can edit dimensions. So we wanted to change the height of this. I'm going to right click on this and click show dimensions. If you want to change that height to 0.75 inches, you can do that right here without even editing the full sketch. And then go up to the top and click the local update, and that will update the size in the model itself. We'll go back and suppress this, and we'll add the semicircular cut, which we'll do by making a sketch on the XY plane. And we can just make a full circle here because all we're doing is cutting through. We don't have anything below the plane here that's going to be affected if we only make a full circle, so that's fine. We'll make the diameter 2.5 inches. Finish that. And we'll extrude it symmetrically through all. Let's see. Make sure that it's a cut, that would help. Now we're going to change the material properties. So I'm going to change the view so that we can see what we're getting into here. If you go to Manage, alright, so we go to Tools and Material, and if you click on Aluminum 6061, and if you click on this little button to the right of it, Add Material to Document and Display in Editor, That allows you to make some changes here. If you wanted to put in any information here, you can. We're going to change some things about the appearance. We want to change the color to a light green. So all I'm going to do is just select one of these light green colors. It's not going to be too specific, doesn't matter. You can see that it changed the color. We're going to change the glossiness to 50. Hit apply, and that's a little shinier. Okay. If you click on physical, you can see the physical properties of aluminum. If you had something very specific and you wanted to change it based on known properties, you could do that. In our case, we don't need to do that, but that allows you to change materials. So this basically covers everything from chapter 7. I'm going to save this as U-bracket and go straight into chapter 8, where we're going to create a drawing of this part. You've already done this by hand. Now you're going to do it in Inventor. So once you have a part modeled, you can make a two-dimensional drawing of it. So if you followed through and went straight into chapter 8, then you don't have to do anything. If you close down and you start it up again, all you have to do is open this part again. And then we're going to go to File, New Drawing. That'll bring up the default options for your drawing. We're going to change around some things. So we're going to go to Manage and Styles Editor. This will show you things that you can change. So right now it'll come up looking probably something like this, or active standard. So when you click on the filter option over here, you can change it to all styles as they note. That'll show everything that is available. And we're going to look at the default standard. I have some things about view preferences. Just make sure that your view preference is set to third angle of projection, because that's what we are going to use under default standard ANSI. And you can click to collapse the standard area. We're going to look at dimension, which is right here, and go down to the default ANSI, and that'll show you options like precision and decimal. If you wanted to make a new version for yourself, if you used a different standard, you can do that from here. This will show you units, display, and text options. Okay. Now we can use predefined drawing sheet formats, which is pretty nice. That gives us the size of the sheet overall and standards for things like the scale that we're using. So if you click where you have drawing resources, click the little arrow that's facing right to expand it. We want to see sheet formats, so we'll expand that as well. We'll double click the B size 2 view, and it's asking what document name do you want. At this point, if you didn't have a file already open, you could choose one. Right now it's pointing me to the U bracket that I already have open, because as you can see down here, that file is already open. So that's the one I want anyhow. I'll click OK. And it doesn't place my views very nicely, but when you hover over them, you can see a little red outline appears. And that lets, if you click, you can drag it. And then I'll click and drag this one. So this is our base view on the left, and this is a projected view from the base. So the projected view can only move if it's the right view in the left and right direction. That keeps it lined up the way you want it to be at top and bottom. So you don't have to think about it. It will automatically do that for you. Then we also want to take a look at what a C-size drawing with 4 views would look like. So we double click that. It's still pointing to the same document. Okay. And again, it's kind of a bit of a mess here. So we'll drag those around till they are where we want them. And since we're not going to actually use this sheet, we're going to right click on it and click delete. Okay. Now the active sheet is sheet 2. Let's change that to sheet 1. So right click on sheet 1 and click activate. Okay. And we do want this, right now it's a D size. We do want this to be a B size, B scale drawing. So we can do, let's click on sheet 1, right click on it, and click edit sheet. We'll change this to a B size. Everything else looks good. Click OK. Now we have a B size drawing. So now we want to add a base view. So we'll click base view. And at this point, you can use your view cube to decide which one you want to be the base. So you could change to have your right view be your base, but right now we do want the front view to be the base. So that is good. The scale that we want is 1:1. Then we can click OK. That creates that base view for us. And then we want a projected view of the top view. So once you click projected, it automatically will do it from the base. And it's showing you approximately where it'll put it on the page. So if you click with left click there, it'll put the box in to show you where that view will go. And we also want an isometric. We'll click. Now we have boxes and nothing has happened yet. There's no view and it's still asking me if I want to put another one down. So right click and click create, and it'll create the 2 views that you clicked and said you wanted. Now this one, when we hover over it, you can tell you're in the area because the red box appears, dotted lines. Right click in there. We want to edit this view. So let's see. That is right here. Edit view. And we want to change the scale of this to 3:4. So that this one's a little smaller. It doesn't need to be as big. Click OK. We're good. Now we're going to start putting in our dimensions. Again, as I said, you can click and drag to reposition. If you click your base view, you can move it up and down away from your projected view, but if you move it left and right, they will go together. That'll keep them aligned that direction. And you can click and drag on this one if you want to move it around as well. Now we're going to go to the annotate section. One nice thing you can do in Inventor is have it basically auto dimension for you by retrieving the model dimensions, because you already put them in the model. So if you click retrieve, click the view you want to do that for, it'll show you all of the dimensions that it has available, and all you have to do is click the ones that you want to bring in. So I do want this one, this one, say this one, and this kind of is a jumbled mess. What you could do is click all of those, and I'll show you how you can sort that out later. Now all of the ones that you clicked, when you click OK, will show up in your drawing. Now if I zoom in here, let's try to get this mess sorted out a little. So this is showing us the diameter of that semicircular cut, which we don't need in this view. So if you click on it until it highlights in green, then you can hit delete and it will go away. We do want the diameter of that hole. We do not, we do want this 2.5 inches, because that is the distance between these two. So we can click on this and we can drag it. Let's move it outside of the model. And then this diameter, if you click on one of the control points here, you can drag it so that it is outside of the circle. You never want to have a dimension actually inside of the item. So I'll zoom out and I'm going to put that up here. And if you click on the numbers, you can drag them so they switch sides if you like. I'll put this in the middle here. Again, don't want this inside of the model, so we'll put it out here. And then you can do the same thing on this view, but I find that this view, when you click retrieve dimensions, it gives you some kind of weird things that you don't really want, so I don't want to retrieve any dimensions from that. You can also just use the regular dimension tool. You don't have to type in the dimensions because it will still retrieve them. You just pick which ones you want. So if I want the inner dimension here, and it'll ask me about precision and tolerance. It's fine as it is. I want the outer radius. Okay, and I want the height. So those should be all I really need there. Now a couple of other things you might recall, that when you have a hole, you need to have a center mark on it. So that option is up here. So center mark, we'll put a center mark in this big hole. One here, one here, one here. And then also you can drag these lines around. So we want to show that this is also centered that direction. We want this one to be dragged up so it goes all the way through here. And then you want to have center lines where these holes are here. So we will use the center line bisector here. You click the two lines that you want to be have a center line between, and it automatically places it. So we've got center mark, center lines. And then we can put some text in. Click the text box up there, and then wherever you want to put it, let's put our institution name. And we'll increase that slightly. And we can put a title in here. We'll make that about twice as big. We'll also make that bold. And it's not perfectly centered in this box, but you can hover over it and drag it around. Doesn't have to be perfect. Then this has only my first name shown because I think it pulls the name from my computer. So I'm going to put my last name in there. And then try to line it up. I'm going to save this. And once it's saved, it will automatically put the drawing number the same as the file name. And we can show that if you make any changes to the part, they will automatically update in your drawing, which is really nice, so you don't have to fiddle with them both. So I'm going to demonstrate that. We're going to go back to 3D model. We'll change in the base. If we right click on that part and click on show dimensions, I'm going to change, look at this from the top. I want to change the diameter of these holes to 0.625. OK. And then when you hit the local update, it will make those holes a little larger. We're also going to change in this hole, or in the extrusion 6, which is the cut, semicircular cut here. I'm going to show the dimensions here. We're going to change this. And what size do we want that to be? Sorry, I lost my place in the book and I don't remember what size we want that to be. Oh, that's dry because we're not changing that one. We are changing the arch. We want the outer size of that to be changed. So we'll show the dimension. We want that radius to change to 1.625. So that's what happens when you lose your place in the book. I apologize. And hit the local update. Now it's updated in our model. If we go back to our drawing and hit the local update, you can see that outer arc has changed its size and our holes have changed their size, but they are not showing the full precision that we want. So if we right click on that dimension and click edit, if you go to the middle tab for precision and tolerance, under primary unit, you can change that to 3 decimal places. And we'll do the same thing on this one. So that should be everything you need on your drawing. You can just submit the drawing file, you don't have to print that. The other thing we can do, if we go back to the part, is we can annotate the part within its 3D drawing. So what we can do is go to the annotate section. We can add dimensions in this view. So we can do things when you click the dimension button, click an arc, you can put the arc in there. Okay. If I want to put the size of this hole, right now it's again only at 2 decimal precision. If we click on edit dimension and go to precision and tolerance, we can again change that to 3 decimal points. Same way we did in the drawing. So now you can go around and add all of your dimensions that you want. You can remember you can move this around and rotate it if it's easier. So for a dimension like this and like this. Unfortunately, you have to click the dimension button every time, but it's very similar to all the other dimensioning that you've been doing. And if something's facing a different direction than you expect it to, you can right click and click toggle alignment. It'll change the direction of it. And then let me hit F6. See, these are overlapping, but again, you can still drag them around. And just make sure you get all of your dimensions in there. But that's not what we wanted, so I can delete that one. And if you just use the dimension button, you'll see it just gives you 0.25. So for this one, we'll delete that, and we do want to use a hole or thread note for that one, which is right next to dimension. And will automatically tell you that that is a through hole. Technically, we could do that for this one as well. And then make sure when you put in this outer radius that you edit that one to have its tolerance at 3 decimal places as well. And then these, kind of tough. Just try to get them so they're not quite overlapping. Then once you have all of the dimensions that you need, you can save that. And this one, pretty much all I need is a screenshot. So you can either go to File, Print, and make a PDF of it, or you can hit Windows Shift S and just make an image like that. That'll copy it, and you can paste it into Word, or you can paste it into Paint, however you like. So that covers everything from Chapter 7 and 8. So you'll have the 2 walkthroughs to turn in, as well as on page 8-37, exercise number 2, the corner stop. So you will make a part for that, and you will make a drawing. So basically do the same thing that we did for this guy, except that you're doing it for the exercise on your own. Make the whole part, make the whole drawing, turn both of those in on canvas. If you got any questions, please let me know. Otherwise, have a great week.